Hi, welcome to Introduction to Amateur Radio Communications. You know, one of the things that all hams share is our fascination with radio waves. But what are radio waves, and what is it about radio waves that make them act as they do? Radio waves are electromagnetic energy. What this means is that a radio wave is made up of two parts, a varying electric field and a varying magnetic field. In a radio wave, these two fields are linked. As the amplitude of the magnetic field changes, it induces a changing electric field, and vice versa. These two fields increase and decrease together, but they are at right angles to one another. The direction in which the radio wave travels is dictated by the direction of the electric and magnetic fields. In this figure, the radio wave travels along the x-axis. This interplay between the electric field and the magnetic field propel the radio wave through space at the speed of light, or 300 million meters per second. This isn't really surprising because, as we'll find out, light is also electromagnetic radiation. In a radio wave, the electric and magnetic fields are always changing. The field strength of both the electric field and the magnetic field start at zero, increase until they reach the positive peak or crest, then reverse direction and decrease until they reach a negative peak or trough, and then return to zero. The amount of time it takes to do this is called the period, and in a single period, we say that the wave has completed one cycle. Note that in this figure, we're only showing one of the fields, but both the electric field and the magnetic field have the same period. Related to the period is the frequency of an electromagnetic wave. The frequency is the number of cycles per second specified in hertz. One cycle equals 1 hertz. Radio waves span the frequency range from about 20,000 hertz or 20 kilohertz to around 300 billion or 300 gigahertz. Electromagnetic waves with a higher frequency include infrared light, visible light, ultraviolet light, X-rays, and gamma rays. As you can see from the chart, radio waves are at the low end of the electromagnetic spectrum. As noted earlier, electromagnetic waves, including radio waves, travel at the speed of light. The distance that a radio wave travels in one cycle is called the wavelength. The relationship between frequency and wavelength is quite simple. Because all radio waves travel at the same speed, 300 million meters per second, the distance that a radio wave will travel, as measured in meters per cycle, in a single cycle, is 300 million meters per second divided by the frequency in cycles per second. Since we often talk about frequencies in megahertz, we can divide both the numerator and the denominator by 1 million, so the equation becomes wavelength in meters per cycle equals 300 divided by the frequency in megahertz. You can also calculate the frequency of an electromagnetic wave if you know the wavelength. The frequency in megahertz is equal to 300 divided by the wavelength in meters per cycle. As a way to quickly refer to different portions of the electromagnetic spectrum, scientists and engineers have come up with the designations shown in this chart. While these designations are somewhat artificial, they are a quick way to refer to different portions of the spectrum, and quite often, the frequencies within each section have common characteristics and applications. For example, the HF frequencies are often used for long-distance worldwide communications, while the VHF and UHF frequencies are used for local communications. Amateur radio operators can use many different bands of frequencies in the radio spectrum. Often these bands are referred to by their approximate wavelength. For example, the 80-meter band refers to frequencies between 3.5 megahertz and 4.0 megahertz. If you do the math, you'll find that a radio wave with a wavelength of 80 meters has a frequency of 3.75 megahertz, which is right in the middle of the band. Similarly, the 2-meter band includes frequencies between 144 megahertz and 148 megahertz. In fact, these frequencies have a wavelength that is a little longer than 2 meters, but it's a lot easier to say the 2-meter band than it is to say the 2.055 meter band. A radio wave with a frequency of 146 megahertz has a wavelength of 2.055 meters. Amateur radio operators can use frequencies as low as 136 kilohertz and as high as 250 gigahertz, although the chart only goes up to 1.24 gigahertz. So, whatever your interest, there are frequencies available for you to use. To become an effective amateur radio operator, you need to familiarize yourself with the different amateur radio bands and know which bands to use to achieve specific communications goals. As mentioned earlier, the amateur radio bands in the HF portion of the spectrum are most often used for long-distance, over-the-horizon communications. The reason for this is that radio waves at those frequencies are bent back to Earth by the ionosphere. The radio waves may even make more than one hop and propagate around the world. Radio waves at higher frequencies, such as those in the VHF, UHF, and microwave frequency ranges, tend to pass through the ionosphere. That's why we tend to use them more for local communications or space communications rather than long-distance worldwide communications. This is one of the reasons that most repeaters operate in the VHF and UHF portions of the radio spectrum. Cell phone systems also operate in the UHF portion of the spectrum. Although you can use a cell phone to talk to anyone anywhere in the world, the radio link between your cell phone and nearby cell towers is a relatively short distance. You can imagine the chaos that would ensue if every cell phone were able to reach distant cell towers. The system wouldn't be able to handle that load. For more information on the electromagnetic nature of radio waves and how they propagate, visit these two websites. Welcome to the fascinating world of amateur radio communications. In the following videos in this course, we'll be discussing what you can do with radio waves, how to choose your first radio, what kind of antenna to buy or build, how to set up your amateur radio station or shack, and how to get on the air and make contacts. Stay tuned. Oh, I screwed up.